Let us find the reactions for this given simply supported beam. So total length of the beam is 6 meter and it is subjected to both UDL as well as point load. So this is the problem statement. So first let us have a free body diagram. So this is reaction RA, this will be reaction RB. So I will transfer the point load as it is. So one is 2 kilonewton at a distance of 1.5 meter. Next 5 kilonewton, it is at a distance of 1.5 meter. Okay. So total length of the beam is 6 meters. So convert this UDL to point load. So this will be 2 kilonewton per meter intensity of UDL and it is acting over a distance of 1.5 meters. So 2 into 1.5, it is 3 kilonewton. So 3 kilonewton. So 1.5 meter. So half of that will be 0.75. From here it is 0.75. So this is your point A. This is B, C, and this is your point D. So this will be 3 meters. Okay. So next this UDL 2 kilonewton per meter and it is acting over a distance of 3 meters. So 2 kilonewton per meter multiplied by 3 meters. So here meter get cancelled. So it will be 6 kilonewton. So it is 3 meter. So it will be exactly at center at this location 6 kilonewton. So this will be 1.5 meter and this distance will be 1.5 meter. Okay. So from here to here it will be 6 minus 1.5. So then it will be 4.5 meter. So this is a force system. So it is coplanar non-concurrent force system. So this problem can be solved by using equilibrium conditions. So for coplanar non-concurrent force system, there will be a 3 equilibrium conditions. So one is sigma h equals 0. That is algebraic sum of all the horizontal forces should be equal to 0. So in this free body diagram, there is no horizontal forces. Next use second condition, that is sigma v equals 0. So already you know the sign convention. So reaction RA plus reaction RB minus 3 kilonewton minus 2 kilonewton minus 5 kilonewton minus 6 kilonewton equals 0. So if you simplify this, you will get RA plus RB equals 16 kilonewton. So call this as equation number 1. Next use this condition sigma MA equals 0, which means taking moment of all the forces about point A. So first force will be RA into 0. Next 3 kilonewton, it will rotate in clockwise direction. So plus 3 into 0.75. Next 2 kilonewton, it will also rotate in clockwise direction. So 2 into 1.5. Next, this 6 kilonewton, it will rotate in clockwise direction. So 6 into 4.5. Next, plus again 5 into 4.5. Next, this RB, it will rotate in anti-clockwise direction. So minus RB into 6 equals 0. So here RA is 0. So if you simplify this, you will get RB as 9.125 kilonewton. Reaction RB as 9.125 kilonewton. So from equation number 1, so your equation 1 is RA plus RB equals 16. So reaction RA equals 16 minus RB. So reaction RA equals 16 minus 9.125. So which is equal to 6.875 kilonewton. So my final answers are, so reaction RA equals 6.875. Next, reaction RB, which is equal to 9.125 kilonewton. Okay, so these are my final answers. So let me verify the answers by using SAP 2000 program. So please note down the final answers. Reaction RA is 6.875. Reaction RB is 9.125 kilonewton. So first, when you open the SAP 2000 software, so first click on File, New Model. So units, default units should be in, so load kilonewton, distance meter, and it is temperature centigrade. Okay, select beams. So total number of spans, so 1, span length 6 meter. So I will remove the restraints. Okay. So you can close this grid drawing. So first job is to assign the supports. So select these two joints. So go to assign, joint, restraint. So simple support, apply, close. Next, load. So it is having point load as well as UDL. So first we will assign the point loads. So first point load is this one, 2 kilonewton at a distance of 1.5 meters. So first select this beam, go to assign, frame load, point load. So select this one, absolute distance from end, starting end. So your distance will be 1.5. So load will be 2 kilonewton. Apply, close. So this is assigned 1 point load. Next, select this beam, assign, frame loads, point load. So if you see here, second one will be 5 kilonewton, which is at a distance of 4.5 meter. So 6 minus 1.5, you will get 4.5. So distance will be 4.5. So your load will be 5 kilonewton. Apply, close. So you can see the 2 point loads. So go to here, options, dimension tolerance, maximum graphic font size. So if can make it as 12. Okay, yeah, now we can, it is clearly visible. One is 2 kilonewton, another one is 5 kilonewton. Next, you need to assign the uniformly distributed load. So select the beam, assign frame loads, distributed load. See here. So first is 1.5 distance. Intensity of UDL is 2 kilonewton per meter. So first absolute distance is 0. Next 1.5. So load will be 2. Okay. Apply. Close. See here. This part is UDL. So again select the beam. Assign frame loads distributed. So you can see the second UDL. So starting point will be 3 meter, ending point will be 6 meter. So intensity of load will be 2. So 3 meter, 6 meters. So load 2 kilonewton. Apply, close. You can see the uniformly distributed load. So select this beam, go to assign frame property modifier. So here weight. So we have to neglect the self weight of the beam. So make weight as 0. Apply, close. So then go for analyze. So analyze only for dead load. See here, your final answers are reaction RA 6.88. So reaction RB is 9.13. So it is matching. So you can view this reactions in tabular form. So select this beam, display, show forces and stresses, select joints. So you can select this tabulated, apply, close. So here it is 6.88 and 9.13. See here. So this is 6.875, which means this reaction RA 6.875. So this reaction will be RB. So it is 9.125. Okay. So in software, so this is 6.88 and this is 9.13. So 6.88 and this is 9.13. So answers are matching. So okay, by this way you can compare your manual answers with SAP 2000 program.